first of all, sorry I can't be there in person for this. I was really looking forward to the opportunity to get a chance to talk with a bunch of the folks that I maybe corresponded with online through all this kind of work, or some of the people that like even taught me how to use UIF. So unfortunate. That being said, hopefully we'll get this figured out by Q2. So I'll come see you guys then. In the meantime, though, I am really excited to have the chance to talk to you about not just UAF for collaborative innovation, but a particular instance of that that we had this past year. So quick personal introduction. My name's Kyle Snow. I have kind of two hats that I wear. The first hat is I'm with the Air Force 96 Test Wing down here at sunny Eglin Air Force Base, Florida. And I'm the digital engineering lead down there. And I also kind of recently have this hat where I'm working with the Test Resource Management Center, specifically in the Joint Mission Evaluation Test Capability portfolio, working on some of their DE stuff there. Last year, we had an opportunity to get together with OUSD R&E DT&E&A, which is Developmental Test, Evaluation, and Assessments. And actually, see, that's what I got on the screen down there, to participate in their Hack-a-Thon 2.0. So we'll talk a little bit more about what that is in just a minute. Spoiler alert, it doesn't have anything to do with actually hacking on a computer. So it's a common misconception. But first, I want to kind of set the stage for the why, right? So if you're familiar with the tested evaluation world, especially in like broader acquisition, you know that everyone just says test, it takes too long, costs too much, and all you do is find out bad news, right? And so one of the things that DTE&A has been looking at is how do we make a complete, a paradigm shift in test and evaluation so that we can move from this event-driven approach to providing verification and validation to something that's data-driven, to something where we have this kind of continuous flow of data. So they came up with this concept called test evaluation as a continuum. Or here you can see it's dTEaaC here, that D stands for developmental. It's got the focus of dTEaaC, right, is connecting all the way from the earliest concept development stages, mission engineering, up through the traditional systems engineering process, and then even out into operations and sustainment, right? The idea being that you essentially have an entire organization of experts on taking data and condensing it, making it decision-worthy, operational. We're the people that get the first hands on the systems, and so we can be providing that value throughout the life cycle. So three main tenets that you'll see here that go along with dTEaaC. The first one being a campaign of learning. So a lot of people think of tests, they think about hey, I got the system, I went out, I flew a plane. But in reality, we're collecting data, we're reducing uncertainty in system performance all the way from R&D through fielding, right? So earliest modeling and simulation, that gives you an idea of what you think the system's going to be like. Subsystem and component testing, that gives you an idea of how certain portions of it are going to perform. And all of this information can be aggregated to form a full picture of what that system is going to look like, not just today, but tomorrow as well. So this isn't just the normal kind of shift left portion of tests. This is also taking that and extending it out into the field through things like digital twin technology and onboard sensors, things like that. With the entire idea being we get to provide that empirical data-centric decision support throughout that life cycle. And how do we do that? Well, one of the things that we have an opportunity to do is take advantage of this new, like, densely connected ecosystem of mission engineering, of systems engineering, of test and evaluation that uses things like UAF and other standards to provide a continuous digital thread, right? So again, just providing that empirical data from wherever it is that test is occurring to whatever stakeholders need them. So a key or enabler of dTEaaC is this thing called the capability-based acquisition reference architecture, or CapyBARA. So here you can see kind of split up into 3 domains. The entire idea, right? This is kind of like the brainchild of Trisha Radachai, who's in the office. Wave, or in the audience. Wave, Trisha. I'm just assuming she waved because I can't see her. But she was looking at a way to kind of connect all of these different domains, and she said, well, instead of just going out and creating my own standard, I'm going to see what's actually out here, right? So this meta model, or reference architecture, is formed from 3 main standards, one kind of for each of the domains that it's looking to connect. So on the mission engineering side, we have UAF. And in fact, this is not just UAF 1.2. We actually reached out to Matthew Haas, said, hey, you had that great Battle of Hoth model. Can we get an idea of what's under the hood, what's coming in for your 1.3? So he passed us along a lot of those added elements here. So what you're seeing is kind of like a 1.3 light, just kind of an attempt at exercising some of those elements there. Then for the systems engineering portion, of course, you got SysML. And then over on the test evaluation portion, you've got UML Test Profile v2. So if you've never heard of UTP2 before, you wouldn't be the first one, but it is another OMG standard. And the great thing about it is, like, back when we started trying to figure out, like, hey, what does it look like to model a test plan or a test evaluation, right? We all sat around and argued, like, oh, well, is a test objective a requirement, or is it a block, or is it a use case, or no? It's whatever UTP2 says it is. So that was a great kind of value. And really what this reference architecture does is, in addition to identifying these core standards, it provides the linkage between them, right? So if you look here, we've got these purple lines that move us from test over to how we relate to the mission, how we realize those mission architectures through tests, and then from SysML, how we provide traceability out to the why, right? Where is this system coming from? Why do we want it? And then from the test world over to the systems world. So how are we verifying and validating requirements? How are we using elements of the system model within our test, and potentially elements that are in other modeling languages, like, well, in this case, UAF, but applied to enterprise architecture concepts as well, which is great, and it looks really nice, but it's kind of academic at that point, right? And we don't want to do something that's just academic. We want to get out there and showcase kind of that value. We want to make the muscle movements, and we want to understand what works, what doesn't, and how we can make it better. So this is when we get into this thing called the hackathon, right? So the DT&E Hack-a-Thon 2.0. Like I said, it has nothing to do with actually hacking, although there was a Cybertruck. Hackathon, an event where people engage in rapid and collaborative engineering over a relatively short period of time. So great sources there, Wikipedia, thank you very much. The idea was, right, like I said, like, don't just talk about it, we want to actually go and do it. So back in September 2024, we went to the CACI facility in DC. We brought roughly 200 participants. We had folks from Army, Navy, Air Force, industry, academia, you name it, with the idea being of providing this accelerated learning environment, which exercises the full scope of this dTEaaC concept, right? Take it from mission engineering and identifying capability gaps and new approaches to getting the mission done, move it through into systems engineering and system development, and then showcase the ability to use that T&E, integrate that T&E information. So we had three main tracks that we did there. We're really going to focus on the detailed test planning track in this case, but we did have these other ones as well. The cyber T&E tools. This one was focused mainly on third-party vendors coming in and showing their ability to utilize their tools to interface with these underlying SysML, UAF, UTP2 models to perform analyses and provide data back to the models themselves. We had the T&E management track, which was kind of concerned with your APM T&E kind of approaches. So things like generating temp style information, things like overall cost and schedule and program test program breakdowns. And then finally, we got the detailed test planning thing. So here you can see a detailed test plan utilize a pre-worked and pre-connected mission engineering and systems engineering model to produce a mission-based test plan for this thing called the Berserker, which we'll get to later. That is and can be linked to both mission engineering, systems engineering elements using what was at that point called the ME, SE, T&E meta model. As you can see, it's a little bit easier to say now than it was back then. So the main constraint here is no documents, right? We're not pressing a button and getting a test plan, right? We want to make sure that this is actually kind of idiomatic to the language. So we got a place to work with in person here with the CACI facility, but what we also needed is a place that hosts that work. And so if you're not familiar with the DoDI 5000.97, that's the digital engineering instruction. One of the surprise things that it has in there is it says the Test Resource Management Center is responsible for providing a digital engineering infrastructure for the entire DoD. So that's pretty important. And so we happened to have we reached over across the R&E lines to go talk to the Test Resource Management Center folks, and they put together a IL2, so completely unclassed distro A, rapid prototype of the Golden Forge integrated development environment that they're providing. So I've got a little picture of Golden Forge over here. This is not what it looked like during the hackathon. It was still great to use, but this is kind of like our vision for where Golden Forge is moving as a platform. It actually right now looks fairly close to that. The only difference being the Netflix browser isn't quite there yet. But anyway, so this was a really capable environment. We had Jira, Confluence, Mattermost, Teamwork Cloud, Cameo licenses. We were hosting MATLAB, and the cloud architects for the platform were literally they're onboarding third-party cyber test tools as the event went on. So really impressive showing there again, 200 people all using this at the same time with no issues. So that was a really great opportunity to get that MVP out in people's hands and kind of walk through it. So, but now for the fun part, right? We're going to talk about what we actually produce, right? What do the models look like? And my one caveat is to say that we didn't do this all in 3 days, right? There was some stuff that was pre-work for the mission engineering, systems engineering stuff, and there was some stuff that was post-work. But that's the distinction without a difference. So, so here we go. So again, we're talking about exercising this entire flow, and so this starts off with a mission. So you heard Aurelius talking earlier about the mission architecture style guide that's put out by another R&E organization, Digital Mission Architectures. And so if you've read that, you'll notice some similarities here, because we reached out to the folks over at Digital Mission Architectures and we said, hey, can we have that model that you're using as a basis for your style guide? So we, again, keeping it nice and unclassed, we are concerned with Operation Desert Storm. Specifically, we're focusing on the suppression of enemy air defense, like they are in their model. And so we extended it a little bit using those UAF 1.3-ish or 1.3 light elements here. So you can see we have our scenario being CENTCOM 1991 timeframe in the past. Got a little cute with that one. We have our individual vignettes that we're concerned about establishing air superiority, which is the one that we're looking at specifically here, as you can see in our execution phases here. And really, we care about two specific things, right? We have our baseline, which is how we do it now with our deep strike capability, which is payloads and Blackhawks going in under the radar. But we also thought, like, hey, what if we could do something entirely different? What if there's a different way to approach this particular mission? Go ahead. Okay. So here you can see we've broken down this mission thread into a series of tasks, and these tasks are traced over into these operational activities on the right-hand side. These are all taken from the Unified Joint Task List, or Universal, whatever, or UJITLs. This is a library that's included in Cameo Enterprise Architect. But these are doctrinal standards that define the different things that we go about doing in the context of executing a mission. One of the great things about having specialized off of these elements is we get automatically all of those measures that are associated with each of these elements. So a nice standards-based traceability. And then we can take those missions and we can kind of align them into that mission thread. This is your very standard, very high level F2, T2, EA kind of approach. But then we said, okay, what if we could do something entirely different, right? What if we had this concept system called the Berserker, which is it's pulled from a bunch of kind of like AFIT or DAU kind of standard systems. And we said, okay, well, very high level, right? We're going to have a ground control system, an air vehicle, an UAR sensor, and we're going to strap a missile on it, right? So we can start in the context of our mission engineering thread, applying these different measures of performance for the individual portions of the Berserkers. We can ask questions in our analysis of, well, if I have a max altitude, if I increase my max altitude, how does that affect my measures of effectiveness and our ability to attain those measures and standards for success? So here you can see we've got that same mission thread, but here we've got systems applied to mission engineering thread. This is the same thing that would have been performed by our Pavlos and Blackhawks. You can see those elements still here in the blue for USA. And we move through our F2, T2, EA process here with the individual activities like launch UAS and control engagement systems, collect post-engagement imagery. These are all actually traced from elements of the Joint Common System Function List, so another kind of doctrinal standard here. All right, so then we totally went out and did a very detailed and rigorous mission engineering thread analysis that totally didn't have anything to do with me yelling across the room at the system modelers, asking them what they put in their requirements so I could put it in the table. And so we decided that, in order for us to be successful or increase our chances of success through the utilization of this concept system, we are going to need a range of 14 hours and a max altitude of 37,000 feet, MSL, max speed of 250 knots. So just kind of giving us those initial thresholds. And now we have this identified need for a new system. We're going to go ahead and turn it over to the program office. So here we have MTSI put together our Berserker air vehicle model here. You can see this is the excellent AFIT photo of it. It definitely looks like a UAV. Definitely looks like it's cheaper than just sending in a Black Hawk. And so the first thing we do, right, is we identify requirements, right? So here, these are the threshold measures of effectiveness that we need to be successful or to meet our measures of success. And because we're working in this densely connected ecosystem of models, this isn't just something that I copy pasted into the systems engineering model. This is something that is actually taken directly from that mission engineering thread. So Trace gives you a source for these requirements, but it also means that if something over here changes, right, you may need to change the requirements. So if we have new information that's introduced in the context of, our mission engineering, whether it's Intel based or whether it's Blue System based, or we have other TTPs or additional analysis, right? All of this can trickle down to our program office so that they can make decisions about how they support the capability. So, of course, we've got these requirements being satisfied here by a couple systems. The main system here is the Berserker air vehicle, and then we have our Hailfire X9 hypersonic missile. And one thing you'll notice, like right off the bat, is this is an extremely detailed model. So we have all these subsystems here, from fuel management to navigation to our EOIR sensor over here. We've got ports, we got data flows. The actual model itself includes this information for the OUSD R&E cyber schema. The idea being is like, what are all of the key elements and properties that we would need on a particular system so that you can go in with a particular tool or a particular technique, grab the cyber relevant information and provide an analysis of vulnerabilities or things like that. We also have a huge number of activities. I think it was like over 200 individual activities, all allocated to the individual subsystems with documentation to go along with it. My understanding is that there was a non-negligible amount of ChatGPT use, but we'll allow it. The more important thing about this isn't the fact that like, hey, we built a system model. The important thing is that we built it according to this CapyBARA approach, and we did the same thing with our mission engineering model. So what that gives us is a repeatable analytic framework that we can use to ask consistent questions about how all of our subsystems actually participate in this overall mission, right? So there's a nasty set of meta-chain queries here that consumed, I think, the entire second day of the hackathon. But what we're showcasing is the ability to go from the lowest level component in our Berserker system all the way up through the subsystems to the system level, across the activities that are allocated to the air vehicle, and then from there to the mission engineering thread functions, to the mission thread tasks, to the mission thread itself, and then ultimately to the mission, right? So you can say, hey, if I lose my executive control subsystem, or if this widget or if this screw breaks, what is the impact here on the mission? So extremely powerful. And the thing to note is that any model, which is quote unquote like CapyBARA compliant, you can just drop this table into the model change your scope appropriately. And all of those relationships that are formed in those meta-chain queries should be the same. So just a huge amount of power there. And a really cool output. Granted, not particularly readable, but that's what other tools like Power BI are for. So now it's time to test. And so we had a bunch of folks there from the STAT COE, the Scientific Test and Analysis Techniques. And so they were able to kind of walk us through this process of mission-based test design, of test design, specifically in the context of mission-based test design, which is a Navy concept coming out of OpDev for the Navy's Operational Test Force. Mission-based test design has 12 steps to it, and because we have all of this data already on what the mission looks like, on what the system looks like, we were done with the first 8 basically immediately, right? What's the mission context? Well, I have everything about the mission context. What are the conditions under which those are offered? Well, I have everything about the conditions. What are the measures? Well, I have all the measures, and I have all the requirements, and I have all of the derived requirements, and I have all of the ways that the system behaves. So I get to just immediately start asking questions about the system's capabilities. So in this case, we have our question that we're asking is, can the Berserker air vehicle effectively employ fires against an early warning radar? This is our test design, or our research question. And we have this test as specifically a realization of that employ fires task here. So moving on, we have a way for using UTP-2 to describe the types of inputs and outputs that we would expect from a design of experiments approach. So a series of factors that could be either categorical or numeric, a signal noise ratio, a confidence level, and a target power that a stat practitioner can then come in and say, okay, well, I'm going to use this to create a model, which is going to have a series of design constraints and terms, each of which have their own power and aliasing values, and some kind of combination of those factors that were directed for us to use, as well as an optimality criteria for doing the actual algorithms here. And so we pass those over to our folks from the STAT COE, and they utilize their JUMP tool, which is a standard kind of design of experiments and stat tool. They provided that output back to us, and I totally had to hand jam all of it because we couldn't figure out how to do the APIs, but don't worry about it. So the idea here is that this allowed us to represent in a standards-based manner what our different experimental parameters were going to be for the test. So now we get on to some more UAF. So one of the things that we wanted to showcase here as well from a value proposition perspective is the reuse of external elements, right? So one of the things we have going on at the 96 Test Wing is we have this enterprise architecture that we're building in UAF. Part of that is a model of all of our test resources. So the idea is like, I want a test engineer or any practitioner to go in to be able to select the capability that they require for their test and to automatically receive all of the information or all of the other resources that they need to get that job done. Okay, so what we have is just a convention that we have these capability configurations, and the capability configurations are going to be all the necessary and sufficient pieces required to go ahead and do that part of the test. So our great example here is our airborne munitions deployment configuration, right? If I want to do airborne munitions deployment, I'm going to need a real-time safety control facility with a range safety officer looking at a telemetry display station, controlling a command transmitter, which is using FTS frequencies to pass data to a flight termination receiver, which is on an RCC 319 conformant flight termination system installed on as part of the instrumentation, test instrumentation kit on the munition, which itself is on a platform, which is instrumented by our weapons instrumentation team, right? So what we get to do is we get to just specialize all of those individual capability configurations. And so now we don't just have a platform anymore. We have the Berserker test vehicle, which is also a specialization of the actual system from the actual model. we have our munition, which is now that instrumented Hailfire X9 hypersonic missile. And what that allows us to do is it allows us to reuse as part of our test architecture all of the information that we've provided previously in our enterprise architecture. So the lines in between the capability configurations here, those were added as part of this test configuration, but the lines internal to them were all populated back when we were doing our quote-unquote enterprise architecture or test resource library. So hugely powerful, a lot of information that you can get from this, a lot of reuse. And I know, like, for doing test planning, you know, it's an exercise in copy pasting the words you put about that resource the last time you used the resource, right? So this is something that's so much more powerful than just copy pasting a description, and really requires a whole lot of rigor to be able to understand what's going on. So the other nice thing about this is that we can just query, hey, what are all of the systems under test and what are all of the resources that we're going to require in order to execute this test. And that can be extended to include any parameters or properties we apply for each of these elements. So, you know, didn't have too much time. We just had types for all of these things. But you can imagine if I included something like the hourly cost of a particular resource, like the hourly cost of hiring a target engineer, or the unit cost of implementing implementing a test instrumentation kit, or the different resource requirements for operating a telemetry receiver, you start to see how all of these components can be automatically aggregated up to start to meet some of those APM T&E kind of needs. What's my cost? What's my schedule? And what is it that I have to use in order to evaluate my system under test? We also have traceability in our actual test. So this is our set of actions that are performed during the test, including schwacking the target. And these are, in some cases, populated by elements that are direct from the system model. So we have that traceability there. But they're mostly also traced to our individual mission functions and mission tasks, right? So you can say, hey, for this particular action, I'm going to take a look at the measures of effectiveness that I applied to transmitting my track data, and I can use those here and then provide that direct traceability. So I can say, like, hey, I flew today, here's what that mission is going to look like in the future. And lastly, we can specify how all of our information is going to be parsed and evaluated so that we can provide this verification. The important thing to note here is that this view is the final end-to-end traceability, right? So I go in, I look at my threshold circular error probable and my calculated circular error probable that's provided from the data that I collected during the event. I can use that to verify our circular error probable requirement, which comes from the system model, which itself is refined from the target lethality requirement, which is traced to that threshold MOE. So, like, this is it. It's start to finish, the entire cycle here. And I was going to put like a kind of takeaway slide, but I couldn't find a good way to do it without seeming corny, because like essentially, like, we did it, right? This is here. This is real. Showcasing that value of the dTEaaC approach to provide an idea of what a system capability looks like through test at all kind of stages throughout the life cycle. So this is just one test, but you can do the same thing for all of your modeling and simulation, all of your concept development. This gives you the ability to connect with other tests as well, right? So when we see how other people are looking at or getting results for circular error probable or time to employ fires, or all of these things, aggregating those up over time for that continuum of learning. The other really important thing about it is like, they have that change curve, right? And you got your innovators and your early adopters, and then you got that chasm, right? And the thing that the chasm is like caused by is that it's difficult to see a new technology like this and take that next step, understand what it is that you can do with it. And so what this does is this provides a tactile example of how you use UAF alongside SysML and these other standards to actually answer the hard questions and get value out of all of this work that we're saying people do. So in lieu of a closing slide, I will put this one up on the screen. So if you're thinking like, hey, that's really cool, I'd like to be a part of it, or I'd like to have input into what that reference architecture looks like, we are working towards getting CapyBARA put into a standard. We're going through CISO. There are a lot of variables, and we decided this was the right way to go for us. For now, at least, that QR code down in the corner, if you scan it, you'll be able to hop to that site once you have your registration. You can just be a guest and it's free. But we really want to see that get moved forward as a standard, and more importantly, we really want feedback on it. So please reach out either to myself or to Trisha, or join the study group so that we can make this as good and as valuable as we want. So that is all I have. Thanks again for the opportunity to kind of show off what we did.